The next barrier synchronizer we're going to talk about is the cyclic barrier, and we'll begin by giving an understanding of its structure and functionality. So it's another barrier synchronizer in Java. It allows a set of threads to wait for each other to reach a common barrier point. So the example, as we talked about before, is the assembly line where fixed-sized groups of workers on a work team coordinate to build various parts of cars that are moving by in phases. One car per team. The team does a certain set of things on it. As I mentioned before, this works for fixed size, cyclic, entry, and or exit barriers. One of the other things you can do with a cyclic barrier, which you really can't easily do with the other synchronizer countdown latch, is you can reset the count manually at any given point. If you reach a point where you're like, okay, let's say someone discovers that the car has a defect. It's like, all right, we're not going to waste any more time working on this car. Let's break the barrier, let the car go, off to some repair shop to be fixed, and then we'll go ahead and regroup for the next car that comes down the line. In contrast, the countdown latch does not enable the count to be reset, but cyclic barrier allows you to reset the count at any point. As with the countdown latch, there's no interface that's implemented. There's no common interface that's implemented for this because it's really just a one-shot thing, or a sort of one-off thing, not one-shot thing, a one-off thing. And it also does not apply the bridge pattern, so it doesn't reuse any of the abstract queued synchronizer mechanisms that we had talked about for the other synchronizers and for countdown latch. Instead, it defines a bunch of fields that are used to implement a cyclic barrier, and this comes back to the question we talked about before, sort of how does this implementation work? And I'll sketch out how it works. It's actually kind of cool. You can see the implementation of this thing here if you go to this link, you can find the source code and take a look at how cyclic barrier works. It's actually fairly straightforward to understand. There's a lock that's used to protect the critical sections of the code. No surprise there. There's a condition that's used for the threads that are part of the fixed-size group of threads that are part of the cyclic barrier work crew to wait upon until they're able to make progress. So it's just the classic use of a condition object. There's a count of the total number of parties, which starts at count, which is the number that's provided in the constructors. We'll see in a second. And then every time someone joins, it gets decremented until it reaches 0. I'm sorry. The total number of parties is just set to be the number of people who are in the work crew. And then there's a count that keeps track of the number of parties that haven't yet called a wait. And that's going to be starting out with the value of parties, and it gets decremented each time. And then the last thing that we're going to have here is something called a barrier action, and that's a hook method that gets called back automatically when the barrier is tripped. So it gives you a chance to reinitialize or shut things down or whatnot for the next phase or the next cycle. So that's just a quick summary of how things work. And if you take a look at the code, you can see the details of what the different methods do under the hood. And I'll sketch through that in a second.